Okay, everyone, this afternoon or this morning, wherever you are. I'm Blaize Stewart. I'm an architect at Wintellect, and I'll be presenting to you today. I am a Microsoft Azure MVP and a partner cloud solution architect on Azure, as well as an MCSE, as a Microsoft certified solutions expert on Azure as well. So I do a lot of work in the Azure space, and Cosmos DB is one of those areas that I have a lot of interest in. You can follow me online at the One Mule on Twitter, and that's my email address there if you want to shoot me an email with questions or other things about Cosmos DB after the webinar. But if you want to pose questions in the course of this webinar, I'll be try to have some time at the end to answer those. There's a place to pose questions in the right on there's a pane for that in the GoToWebinar software. So with no further ado, let's dive right in and start talking about Azure Cosmos DB. So a few things about Wintellect itself. Wintellect is a consulting company and a training company. So we have a consulting line of business that we do application architecture and development for mobile, as well as cloud-based apps and on-premise things. We also have two lines of business related to training, and that's an instructor-led training where you bring us on site and we will train your developers. And we have trained over 50,000 Microsoft developers and have a deep partnership with Microsoft Learning. So we do a lot of the MOOC courses as well. And then we also have a on-demand training service called Wintellect Now, which has a lot of videos related to the latest and greatest technologies. It's a subscription-based service, so you can watch videos and learn about all the latest tech there is on there. We also have a lot of books out there that have been written by people from Wintellect, some more popular ones by our founders, Jeffrey Richter, John Robbins, and Jeff Procyse. And there's a number of books that are available out there from Microsoft Press, as well as other publishing venues. And some other highlights, we have multiple MVPs. We are the 2018 IAMCP Gold Partner of the Year for the US and worldwide. We have a DevOps competency with multiple Microsoft ALM Rangers, and we are a Xamarin Premier Consulting Partner. And we have a lot of other things that we focus on as well. And that's a little bit about Wintellect, but let's dive in and start talking about Cosmos DB. So what is Cosmos DB? Cosmos DB was launched in May of 2017, so it's not as a product offering from Microsoft. It's not really that old, but it's built on something that Microsoft's had for a while, and that's Document DB. Document DB was just a single paradigm offering from Microsoft, and it allowed you to do something very similar to what you could do with MongoDB, and it had a Mongo API, but they expanded on that and added several other paradigms to that. So that you could have things like key value store, column family, documents, and graph. And we're going to look at these paradigms later on in this presentation. Cosmos also supports server-side programmability, and this is something unique to a lot of document databases that are found online, and that is the ability to do store procedures, triggers, and user-defined functions. So it's, again, it's a multi-paradigm database that has server-side programming as well as the ability to query it using multiple APIs, and we're going to look at those in the duration of this presentation today. Cosmos DB is dynamically tunable. That means that you can scale it on the fly to meet different load demands. So if you need to scale out or scale up or scale down, depending on the load, you can do that dynamically without disrupting your production environment. It automatic partitioning, it distributes data over physical partitions as well as based on the load that you apply to it and the size of the data that you have. And then Cosmos DB has global scale. Literally with a single click of a mouse, you can scale Cosmos DB to multiple Azure data centers around the globe, and it automatically indexes. It literally will index every field that you throw into it, and you can also build compound indexes as well if you need to do that as well. Another thing that is kind of cool with Cosmos DB is it has 5 different consistency models. If you're not familiar with what consistency is, it's how soon data writes will show up in your database across a distributed database, especially. So what most people are used to with database consistency in the current context of SQL Server or something like that is the ability to have strong consistency. That means your writes show up immediately when you run the query. However, in some models, that's not always the best thing to do. So there's other models such as bounded staleness, session, and so on. The two most popular being strong and eventual consistency. But Microsoft has offered some mitigated models that are stronger, have stronger consistency to some that are very relaxed consistency. So bounded staleness would be one that would, it's bound basically to a time indexed, so a staleness window. It won't be any data that's written within a certain period of time will be consistent across the replication, whatever is defined. Then you have something as session-based consistency, which means it's basically the session that is writing the data will be able to read that data as well. And then consistent prefix, this one's a little bit hard to explain, but it's basically the number, depending on the number of writes that are out there, but there's no guarantee that the reads will be in the correct order. And then eventual consistency, there is no guarantee that any given data will be read in any given order. It just means that clients may see older data on newer queries and newer data on older queries, while on consistent prefix, there's some of the ability to have some level of consistency depending on what is written. Now, this is something that's a little bit hard to explain. It's something that's visualized better. So I wanted to do a quick demo of this and show you visually how this works, because Microsoft has a real good visualization of this on the Azure Cosmos DB portal. So I want to drop over to Azure Cosmos DB and pull this up, and then we can just to show you kind of how what this might look like visually. So I'm going to log into this right here, and I'm on Azure now, and that's going to pull up my Azure portal, and I'm going to pull up my resource group, and I'm going to show you the portal for Cosmos DB. I have created here a Cosmos DB. It all looks pretty much the same depending on what you're doing, but it's going to vary a little bit depending on what you're doing between the different paradigms. But this is a graph database that I have defined here, but what I'm going to show you now is going to look very consistent across all the different paradigms that you can use in Azure. The main thing is this going to look different as the Data Explorer. So this is the Azure portal experience for Cosmos DB. And what I wanted to show you first is the consistency models that are available here, since that's what we were talking about. Now, this visualization kind of shows you what it's talking about. So if this musical notation here represents the writes that are happening, and if I select eventual consistency, there's no guarantee that the reads and writes will be in any given order, and that's what these different regions down here are showing. So if I write blue, it might show up in blue, purple, magenta, yellow, and green, while this one might read it red, green, and blue later on in Eastern Australia, depending on the latency between the various data centers. So this is eventual consistency. So it's not very strong consistency, but if I click on something like strong consistency, it's going to be the same in every one of my data centers that I am replicating to. And this is for example. So this visualization shows you kind of what that consistency model would look like. Balanced staleness is going to look like something like this. And there's a delayed versions. So in some regions, you're going to see the reads before other regions do. And so you end up with something like this within a given time within a given time index. This one shows you the consistency across sessions. So session A will always look identical to session A, session A, session A in regardless of the region, but in a session B, it might not be consistent in that one as well. And then consistent prefix, if the reads are going to look something like this across my regions. So These two reads have something that looks a little bit more consistent with what I have, with what I'm experiencing here. But it looks a little better than it would have had otherwise. And then eventually, again, there's no guarantee that anything will be read or read in the order that it was written, depending on who writes it. So this little visualization gives you a nice look at how consistency models work based on musical notes on a scale. Now, all that to say is this visual is that understanding the consistency whenever you go into Azure Cosmos DB is one of those things that you have to understand what's going on so that things will show up in the correct order whenever you're writing them, depending on the consistency model that you do choose. Now, with that said, though, there's other things that are tunable on there, on Azure Cosmos DB as well, and we're going to look at some of that here. Within the database here, there are several overviews, things that I can look at on the overview tab. I have the ability to see where my regions that are configured. If I wanted to set up new regions here, if I can enable geo redundancy here, and I can replicate data literally with the click of a mouse. So if I want to replicate to Canada East or maybe South Central US, I could set that up, and then it will replicate data globally using a single click of a mouse. And so I can scale out globally using this horizontally. There's also several other things I can do within the context of this portal here. If I need to scale up my database, I can do that as well. I'm gonna, okay, that's okay. That's my consistency model here. If I need to scale, I can do that in my Data Explorer, and I can set my consistency levels. I mean, set my my scale up to more DTUs if I need to. So this again is I've got it set to 10,000 not DTUs, RUs on Cosmos DB, and that's a fairly low amount. I can scale up to literally millions of RUs. So combination, and these are basically request units that are used for read and write operations on Cosmos DB, as well as things like store procedures and other things that you might be executing against them. And that's all these RUs determine how much you end up using. So this one is costing me about 80 cents an hour. So I created this today. That would cost me about $20 a day. So a lot of other things you can do with Cosmos DB is replicate. I can set up security around this. I can actually bind it to VNets on Azure. There's my keys. I can set up access control to the actual resources on Azure using IAM control integrated with Azure Active Directory. I can bind it to Azure Functions and things like that, which is kind of nice, which is a new feature they've recently added. And I can do other things like write store procedures and triggers and other things through the portal right here, but I don't, because I'm using a graph database, I don't think that's enabled, but I do have the ability to click around in this thing and see what I'm actually doing inside of my, oh, I do have store procedures available here. If I would have to access those through the portal here if I needed to. I can create new store procedures, new queries, and so on, or I can click around on the graph itself and then and explore the graph and using this visual interface here. And I'm gonna look at this a little bit later when I talk about graph APIs. So that's kind of a quick overview of what you can do inside of Azure Cosmos DB in the Azure portal. There's a lot more to it than again, for the sake of time, I'm not going to be able to go over everything here, but I do want you to see how it works and see what it looks like. It's actually very intuitive, and they've gone through a lot of iterations of this to make it even better over the last few years, and or the last, I guess, year since it launched, and they continue to add new features to it. They have some cool new features that they announced at Ignite was the ability to have multiple masters in Azure Cosmos DB, which and then the ability to have some other scalability options, so you can replicate more quickly across regions and things like that. So a lot of cool features they're adding constantly to this. So let's go back to the slide deck and look at some more things related to Cosmos DB. I'm going to dive into the paradigms themselves. Now, Cosmos DB is fundamentally a NoSQL database. It means that stands for NoSQL, or what we might call non-SQL. And not only SQL depends on the context, but generally it's synonymous with a document database. So document databases can be is basically anything that stores something in a relational or non-relational form. I'm sorry, something in a non-relational format, such as JSON data, key value pair data, something like Redis cache would be considered a NoSQL database, or Cassandra would be considered a NoSQL database. And this one, being originally a document database that will store documents like JSON documents, was a NoSQL database. And it also has Mongo API available, so you can use document databases on Microsoft Cosmos DB. If you have a Mongo database, you can lift and shift that to Cosmos DB and use the Mongo API there. Some NoSQL offerings come with a SQL-like language, not to confuse NoSQL with SQL-like query languages. The ability to query something with a SQL-like language does not imply that it's SQL. It just means that it's a NoSQL database using document databases. In other words, it's not an RDBMS like Oracle or MySQL or Microsoft SQL. Some things that are comparing this to what is a more familiar context, and that is a relational database. Non-relational databases store data in a hierarchical format, such as documents or key value pairs, and SQL databases, which you're used to with Oracle or MS SQL, store things in tables. NoSQLs have flexible schemas, while SQL databases typically have very strict schemas, and so it's defined by the database schema and how those every table has a set of columns, and that every record will then have a representation in that record for each column in that table. Data in a NoSQL database is generally denormalized, and it's while data in a SQL database is normalized, and the relationships are handled through joins. Denormalized data can be represented in an object for the entire record in a NoSQL database. In other words, you can take an object, a JSON object in JavaScript, and serialize that, and everything is embedded in that object, and then write that data into NoSQL. Because it's denormalized, you might have some data redundancy across documents in data in a NoSQL database, and sometimes that's to your advantage, and other times it might you get data staleness, so you have to take that in consideration when you're writing against these things. And that's one reason that Microsoft introduced the ability to have triggers and user-defined functions and store procedures, is so that you could update records and other things in your documents when things happen in your database. NoSQL databases scale well horizontally. By that, we mean they can scale out to new nodes. You can add new nodes to them rather easily, and you can also get database sharding. By that, we mean you can have subsets of your data stored in different nodes, while in a SQL database, that's not as easy to do. It scales well vertically. It scales better by adding more CPU and more compute and more faster disk access than a NoSQL database does. So to scale a SQL database, typically we've added just more CPU horsepower. NoSQL, we scale it by sharding the data, creating subsets of the data, and then spreading that across multiple nodes, like you might do a microservice type architecture or something like that. NoSQL databases are typically more ACID compliant depending on the technology, and then SQL is definitely ACID compliant. This gets into that consistency that we were talking about a moment ago. So typically NoSQL is not always strong consistency, while SQL is almost always has strong consistency. And again, lastly but not least, NoSQL is typically very useful for rapidly changing environments, or ones that the schema is changing rapidly as well. And SQL is very good for heavy query or read-heavy operations. So a typical environment doesn't always just have one or the other. They will typically have a mix of these two. Like the applications are going to be driven by NoSQL, but when they need to come, when it comes to reporting and things like that, data will be aggregated and put into some kind of SQL database to where it allows it to be queryable and reports can be generated from that. So depending on the context, these two will typically be used, NoSQL and SQL can be used hand in hand with one another, depending on the context. It's not an either or option in every case. You just have to have your ETL process out of your NoSQL environment into SQL or vice versa, depending on what you need. So just it's not, don't try to think of these as competing technologies, but complementary technologies that can be used for different tasks and different kinds of jobs depending on what you're doing. Again, just a few words of warning here. NoSQL is not a replacement. Like I mentioned, it's just another tool for different job. When you see performance metrics that compare NoSQL to SQL, I tend to take these with a grain of salt because they can be misleading because it's comparing apples and oranges. And as we get into some of the paradigms, you'll see why it doesn't always translate well between SQL and NoSQL databases. And the technology stack doesn't determine the data store. SQL and NoSQL can be accessed from all popular development platforms. So NoSQL, for instance, can be accessed from Java, .NET, Node.js, whatever it may be, as well as SQL databases. So Microsoft MS SQL can be accessed from Java. It can be accessed from Node.js and .NET, as well as NoSQL APIs as well. So there's no one tool that you're restricted to. So you can pretty much use Cosmos DB with whatever you're already using if you want to go down that, or whatever you're comfortable with, and use it in that development suite that you're already using for your applications, .NET, .NET Core, Java, Node.js, other languages like Python, all support most everything that's represented in Cosmos DB, as well as SQL databases as well. So this is generally not going to be pitched as a replacement for a SQL database, but another tool in your toolbox for doing things with data. And it's got a lot of different paradigms and uses there. And again, I want to mention data distribution across data distribution in Azure. We saw that in the portal. You can literally, with the click of a mouse, replicate your data to other data centers in Azure. And it's got geofencing if you have to have compliance issues. It's got automatic failover between regions. You don't have to, and you can define these policies if you want to. But you don't have to necessarily change your connection strings to do this. So Microsoft's got all the routing figured out to fail over between regions. So if their region fails, you can fail over to another region if your data is being replicated there as well. It's got read writes between regions based on policies as well. Again, pick the consistency models, and that will determine read write between regions, as well as where read copies exist and write copies exist, and where read and how you set that up based on your policies. And then data distribution can provide 99.99% available SLAs with sub 15 millisecond latency. Depending on what consistency models and the level of replication you got going on, the data distribution though can be very fast. And this typically happens very almost instantaneously. So a lot of those consistency models we were looking at, you might have eventual consistency selected, and you might not ever see any cases where you actually have a problem with that eventual consistency being an issue, because the replication does happen really quickly. Just a word of warning though, just because it doesn't happen often doesn't mean it won't happen. So if you need that stronger consistency, do select it. But just the caveat there is stronger consistency does imply higher cost, but the more eventual consistencies are lower cost because it's got lower you don't have to worry about the replication happening instantaneously. And so just something to think about whenever when you start thinking about using Cosmos DB for your applications. Now, start diving into the paradigms that we have here. The first one we're going to talk about is the document DB, and the document database in Cosmos DB has the document DB, which is a Microsoft technology, and then the MongoDB API, which is the one that's based on the open source project MongoDB, and they both address the same kind of data store, which is a document database, which is essentially just storing JSON documents in a database, and it gives you the query language that you can use to get data out of those documents. And they compared side by side, they're paradigmatically very similar, but there's some trade-offs between the two depending on which one you go with. Document DB has got a very simple query language on document database. It does support user-defined functions, triggers, and store procedures on Cosmos DB. But the trade-off if you're using MongoDB is you've got a much richer query language with aggregation pipelines for doing data aggregation, which doesn't exist in Document DB. However, it does not support those things like user-defined functions, triggers, and store procedures. And so the ability to have a lot of the store procedures and triggers and stored user-defined functions, triggers, and store procedures versus strong aggregation pipelines is typically the determining factor of which API I'm going to use in Cosmos DB between these two different APIs. Document DB versus MongoDB in terms of ACID compliance or that consistency. Transactions are performed through server-side scripting to ensure ACID compliance if you need it. So if you need to do transactions with store procedures or triggers, you can have that strong ACID compliance with that in Document DB. With MongoDB, level of atomicity, high levels of atomicity are possible with MongoDB, depending on how you set it up, and with partitioning and how your collections are defined. But out of the box, it doesn't do it automatically. But you have to configure it to do that. And then Document DB has a very robust security model. We're not going to dig deep into that, but it does give you the ability to have users all the way down to the collection level. MongoDB has very little inherent security. It doesn't mean that it doesn't have it, but you can turn it on and it becomes available at that point. So the document database has some, again, it's storing documents. They're listed as a key value that's stored as to identify by key. The database provides a SQL-like language for querying it, and we've already talked about that a little bit. And the both Mongo and document database have it's a SQL-like language, but it's not SQL in the sense of ANSI SQL or what you might be used to for traditional databases. So both of them support, select from, and then you can have a where clause and return something that looks a lot like a record set with that select statement. However, it's not apples to apples with a RDBMS with SQL against tables, and it doesn't give you the ability, for instance, to do inter-document joins. It doesn't support that, but that's something that's very, but if you want to do joins between tables in a traditional database, that's very easy to do. So it's a SQL-like language. It's not full-blown SQL, so don't get excited about that, but it does give you the ability to query the data and write data back to it as well through that SQL-like language. Another paradigm that exists on Azure Cosmos DB is a key value store. This is a very simple one. It just stores keys and values. You have a key, you have a value, anything can go in that value. It can be lists, arrays, blobs, strings, documents even. And these are just simply addressed by using the key. So there's no query language that goes against this. And it's just basically some kind of key that gets indexed, and then the value is just whatever you stick in there. This one isn't, I haven't seen this one used a lot with Cosmos DB because there's other ways to do this on Azure, but it does exist, and so I do want to mention it as well. This is a less common used one in Azure as well. It's a common column family database or a column store database, and this uses an API called Cassandra. From Cassandra, Apache Cassandra, which is a very typically used in big data applications. And the reason why is it gives you the ability to shard data, essentially partition data based on records. I won't call them records. They're really what we might call a column family, which is a collection of rows. And each row has its own unique set of columns, and some of those columns might be used across multiple rows. And so every column every row is essentially has a column, a value, and a timestamp. And the schema for these can be arbitrary. There's nothing that determines what goes inside of any one of these records that end up in this database. Now, the real advantage of this, though, is that because it's more column oriented versus record oriented, it allows you to partition the data across multiple nodes, but it gives you the ability to query on the column very quickly across all of those nodes. And so this is the column orientation of this allows me to have aggregates across columns. It allows me to do a lot of querying across columns that would otherwise take a lot longer to do in a traditional database. And so this is essentially like doing pivots in Excel, and that's the way I like to think about this. If I want to take my data, do a pivot on Excel, I can see that data from the other way, look at it from the columns in Excel as if it were a record, or sorry, a row in Excel, and then that gives me the ability to see, aggregate data or data such as that, similar to a pivot in Excel. And that's where this really shines. And so it gives me the ability to do a lot of those kind of big data analysis projects in a partitioned environment, so I get really high throughput on my queries in this case because of that. And that's typically where Apache Cassandra is used, and then they have the API for that. So if you ever have to set up an Apache Cassandra cluster, it's no simple task. It requires some fairly beefy hardware to do, and it's not for the faint of heart. And you can do it in Azure using virtual machines, but it's much easier to do it in Cosmos DB and just spin it up there and then scale it dynamically using Cosmos DB, and then have the Cassandra API available to you to write those very complex cross-column queries that you might need for big data analysis. So this is a very useful one for that purpose. This is one of my favorite ones on Cosmos DB, and it's the graph database. And the graph database is very cool because it gives you a very unique way of doing data on Azure that is not typical, that's not being seen up until recent years with some things like Facebook and other social media sites, where they started to introduce this idea of graph databases into the popular mind share, if you will, of development and developers. It kind of grew out of the social media space, but it's found applications in a lot of other places as well. And a graph database, essentially what it does is it takes the idea of vertices and edges and then puts it into a database form and gives you the ability to query based on vertices and edges. A vertice is essentially your nouns. Think of that as these circles, these objects that are here. So I have all these objects here, and then the edges are the relationships between those. So if you can think about this from the social media perspective, you would be like, your social profile would be that represents you would be one vertice. You might have a page for a band, that might be a vertice. There might be a page for a restaurant, that might be a vertice. And the fact that I like that restaurant would be the relationship that would be established between those, and those are my edges. And again, social networking, geospatial data, I'm going to do a demo on that in a minute, and IoT. IoT's got a lot of applications here because it allows me to map complex IoT networks between things like thermometers and cameras and other sensors in a complex network, and I can see, what are the relationships between my sensors and the machines that those sensors are monitoring, and then what are those machines connected to, and what's the process. And there's a lot of other things that I can use graph databases for, especially in the IoT things, and get data out of those systems with IoT. And geospatial, think about things like trucking, trains, planes, and automobiles, geospatial data related to that. So vertices here again, inside of a Cosmos DB, I can set up vertices, and any one of these vertices can have a arbitrary set of properties. Robin has a name and an age, and her laptop has things like CPU, RAM, the resolution of the monitor, and then the operating system, what operating system does it run? Robin has a phone, what OS does it run? It runs Android, and so on. So the idea that you have operating systems, phones, or devices, I should say, and he's interested in something like football interests, or located in every, like a location would be my noun, my located would be my edge. And the edges typically represent verbs, and it's the relationship between all of these. These can also have properties as well. You can say an edge knows something, like Robin knows Thomas, and something about that knowing, say he knows, how long has he known her? 15 years, 20 years, or something like that. Robin uses a laptop, and it might be something like uses daily, or uses at work, or something like that. Just some kind of property that's associated with that edge that you can assign on that edge as well. So edges and vertices combine to make a graph database, and it's kind of a cool application for it. The Cosmos DB Graph API is based on Gremlin, and now it doesn't implement the full feature set of Gremlin, but it's pretty feature complete as of now. It has the ability to have you can still do all the user-defined functions and triggers, but you can't necessarily access those through Gremlin. You have to use the .NET SDKs to access those. However, you can query the language, write data to the Graph API using this language called Gremlin. Now, Gremlin is based on Apache Tinkerpop, which is a open source project from Apache, and it has several implementations, probably the most common one being Neo.js. If you want to run a dev environment, Neo.js would probably be the closest thing to it. And Tinkerpop is a client that you can use to access Gremlin databases, including Cosmos DB. It's a utility for that, or you can use the Azure portal, which is my preference for testing queries out. And now I'm going to show you that in a moment with a demo as well. So it's very cool. And there's no limit to the supported frameworks and languages that you can use with Cosmos DB. As I mentioned earlier, you can use Node.js, .NET, Java, but there's also Python available. Most popular languages that have available APIs for these. And then if it's not supported, there's also a REST and a SQL API, for whatever you might be doing against your databases that you're putting into Cosmos. I'm going to do a demo here using Cosmos DB with a Graph API and a .NET app to run on top of that, just to show you how you can use this. And this is just an example, a sample app that I have written for this. But first, I'm going to flip back over and look at Cosmos DB with the Graph database. So with that in mind, I don't have demos for all of the models for the sake of time. I didn't prepare one for Graph, but they kind of all work the same from the angle of Cosmos DB. And once you deploy the database, you will have your portal available, and you can go into Data Explorer and you can run queries against that database. So everything in Cosmos DB is organized around a database. In this case, my database is called airports. And then I have in that database a collection called Thailand. So my graph, it maps onto my collection. Now, if I set up a document database, that would be called a collection here. But in this case, my collection or my graph is what I'm querying here. So if I want to get data out of my graph here, that I can write a query using Gremlin. Now, Gremlin is, again, I'm not going to give you a primer on Gremlin. You can read about that if you want to. I'm going to click, I can get a list of all of my vertices by clicking g.v and open paren, and it'll give me a list of all the vertices I have in my database. Now, this is a small database that I've done for demonstration purposes. Now, this is giving me a visual representation of the relationships between all of these as well, based on a central one. This is a list of airports in Thailand, essentially what this is. So if I click on Brai Airport, I'll get this and it'll show me connections to it, or I can click on Don Muang Airport, and that will give me Don Muang and show me all the connections to that, or I can click on another major airport in Thailand, which would be, I don't know if it's got listed as Bangkok or Suvarnabhumi Airport on there. There's Sukhothai. Chiang Mai's got a lot of airports connected to it, and Suvarnabhumi Airport is the major airport in Bangkok, and it's got a lot of different connections as well. So you can see the connections based on this Graph API. What I've done here is I've created vertices out of the airports themselves, and all of the edges are based on flight data that I got from a flight database. And so the edges are representing Suvarnabhumi flies to Chiang Mai, or Suvarnabhumi flies to Phuket, or I can go to Chiang Mai and get the Chiang Mai flies to Phuket, or Chiang Mai flies to Krabi, and you have the ability to have those airport the flights represented by edges in my graph database here. And so that's exactly what this is doing. So in the ability, with this in mind, I do want to show you some code that I have used to build out this this particular demo with. I have down here my application. Now I want to show you my controller here, and let me stop. It's not running at the moment. This is my simple application here. I don't want to go into great detail about what it's doing. This is a .NET detail, but I do a .NET app. I do, however, want to show you that's not needed anymore. Oh, I hit F5 on accident. I don't need that anymore. Oh. And this is setting up my connection with here. So notice what I've done up here is I've imported my driver. This is a Gremlin driver for .NET. Like I said, there's SDKs for most every popular framework out there. This particular one is using .NET Core. And I wrote this app in .NET Core to have a web API that returns data back from my Cosmos DB, and I'm going to have a single page app that I'm going to use this with here in a moment. Now what this is doing is it's wiring up my settings for my database. Notice here I have my Gremlin DB. I'm going to delete this so you can't reuse this key later on. But this key is my key out of, bring my code back over here. And here's my settings for this. And here's my code and .NET app. And I have my string that represents my host name. I have my auth key here. And here's my database and collection. Notice that mapped onto the graph that I was defining earlier. And what this does is it sets up a Gremlin server connection, and gives me a Gremlin client, and then I can run queries against that Gremlin client down whenever these web APIs are run against it. So this is simply mapping an API / airports, and then I have several get methods wired up depending on what I'm calling here. And this is being hit by a single page application called index.html. It's just a single app that essentially just wires up a Google Maps and it will goes out and gets a list of airports, and then it'll plot those on a Google map. And then if I click on the airports, it'll go out there and do a query for the destinations that airport connects to, and then it'll plot those on the map as well. And so that's what that controller is doing, is it's going out to Azure Cosmos DB based on what's passed in. So I could pass in an origin, and then this query goes out and gets me the destinations that are connecting from that origin, and then it returns those back to my app, and then it puts those on my map. So let's fire this up and see exactly what it does. I'm going to start this in IIS Express. Okay. And let's pull up my index. And there's my map, my Google map with all my airports that I have in my database plotted on it. So we looked at, on the Azure Cosmos DB, we looked at a lot of the airports related to Thailand, and we saw them visually in that. But this gives you the same kind of feel by showing you the edges between each one of those by doing that query against the database. And it's running pretty quickly right now because I have very low consistency turned on. I have eventual consistency turned on, so I've got fast reads, fast writes, everything. It's very quick on this one. So what I'm doing is I'm clicking on airports, and it's going out there, querying the data, sending back those routes to me, and then populating this this map here with those routes. And the more I click, the more I get on my map. So I can click on any one of these airports. So if I go to the Bangkok airports, there's two of them, Don Muang and Suvarnabhumi. I get a lot of connections to other airports in Thailand based on clicking on those nodes. So if I reload that just to show you, zoom in a little bit, there's my airport. This one is Don Muang. And then I got a lot of connections from Don Muang and a lot from Suvarnabhumi Airport to other parts of Thailand. So that's using some of those Gremlin queries out of Cosmos DBs. And this will give you a relative idea of the kind of performance you can expect from it too. It gets decent performance of getting data in and out of Cosmos DB, depending on the size of your database, how you have it partitioned, how many RUs you have turned on, and so on. All of that plays into that as well. Let's go back to our deck here. And look at a few more closing thoughts. Performance and costs these are based on request units per seconds or RUs. This is a function of consistency. Like again, strong consistency requires more RUs. I have the lowest one. I have eventual consistency, so it's very fast, and I'm not using very many RUs with that at all. If you're doing a kind of an entry level and you just want to play around with Cosmos DB, a minimum of 400 RUs is needed for a single partition, and or 100 RUs per partition for unlimited. I have the unlimited plan right now, and that's what and so I have the ability to use this in a different way. But I had some of my RUs at a pretty high up to about 10,000, I think. And then typically writes are more intensive than reads. Less relaxed, like I said, less relaxed consistency models require more RUs. So strong consistency is going to require more RUs simply because it has to sit there and wait for it to replicate to all of the other data centers that you have selected for replication. And now obviously, if you have store procedures, triggers, and user-defined functions, those will consume RUs as well. And you can use these two links here, the capacity planner and the pricing calculator, to get a relative number of RUs that you'll need for your data set. And then you can take that data that's output from the RUs and plug that into the capacity planner for Azure to give you a relative cost per month based on the number of RUs that the capacity planner recommends for your database. So those two links are very useful for planning purposes. But again, with Cosmos DB, you can scale up or scale down depending on the patterns that you see in your usage, and you can always scale up, and scale down dynamically depending on what you're doing in your and based on times of day. Like you might see more load during the day and then none at night, and those you could have scripts to scale up or scale down Cosmos DB or something like that. Some security considerations. IP, it has a built-in firewall. You can connect it to VNets, and you can restrict access from other data points. So you don't have to turn access on by way of the public internet. You can actually do this. You can restrict access from nothing on the internet and just attach it to a VNet and only allow things attached to your VNet to attach to it. It provides TLS 1.2 into encryption, data at rest, data replication and failover, which we've talked about already. You can do Active Directory role-based access control to the database. It meets ISO 27001, the European Union's compliance, as is HIPAA compliant, and among many other things like with data sovereignty and geofencing and all those other concerns that are brought up whenever you start to talk about putting data online and in a cloud. Azure Cosmos DB out of the box supports a lot of various security features, and you can turn those on and off or implement those very easily with Azure Cosmos DB. But there is a shared responsibility with Cosmos DB. It's a managed platform, so Microsoft is going to provide platform and physical security. It falls to the user to turn on identity and access management, endpoint security, and these are all shared responsibilities that you have to have with Microsoft whenever you're building out your applications to use this. So you make sure that you lock it down to the needs that you have, and that you're addressing compliance concerns for geo fencing, for HIPAA data, and so on, that you might need to address whenever you deploy data to Azure Cosmos DB. So again, that's one of the things that it does very well, though, is the ability to be able to be compliant out of the box with the ability without having to set up a lot of complex infrastructure as well. So that wraps up the presentation for today. I hope that if you have some questions, go ahead and pose those now. There's a few things that we can do as follow-ups. You can follow me online. You can do a skill up with an IoT training from Wintellect, and we have training available for Cosmos DB. So if you want to skill up your developers on Cosmos DB, we have trainers available for that. And we can also help you out with your project as well. If you need consulting with Cosmos DB as well, we can come alongside of you and help you use Cosmos DB to maximize the Cosmos and use it most efficiently and cost effectively for your application. So I definitely want to take some questions here. Since we have some time here. So there's already been several questions asked. Let me see what's going on, see what we got here. Why did MS create a DocDB Cosmos given that MS SQL already existed? I think I answered that in the presentation. It's a SaaS offering. It's a SaaS offering from Microsoft, software as a service. I'm sorry, PaaS offering, platform as a service from Microsoft. That's why they created it. You don't need. It's another tool for doing a different kind of job. That's why NoSQL exists. It's not a replacement for MS SQL. It's a complementary technology to it. It does a different kind of job. Another question on consistency. Are writes stalled until replicas catch up? Not necessarily, depending on the level of consistency. Yes, I did have a typo in there. It's dated. It should be denormalized, not demoralized. On consistency, are writes stalled until replicas catch up? Are writes stalled until replicas catch up? No, depending on on the consistency model. You choose strong consistency, the writes will be delayed. They will happen in the order that they're written. But the more relaxed consistencies, no, there's no guarantee of that. See, another question is, what are some of the use cases that I would see for Cosmos DB instead of SQL Server? I think I mentioned a few of those in when we looked at some of the paradigms. Like again, for the graph database is very good for showing arbitrary relationships between various kinds of objects. So I can link one object to another object very easily, which if you had to do that in SQL Server would be very hard to do. Like you'd have to create a lot of joining tables, for instance, and with a graph database, I don't need those joining tables. I can arbitrarily link any object to any other object and query it based on those links that exist. To do those kinds of joins in something like Microsoft SQL would be very hard to do because you would have to do it it's a per table join. So your queries would be very complex if that were the case. Graph API is one of those that I think Cosmos DB being used a lot. Cassandra is another one of those things for the ability to shard that data across a lot of different nodes and then write column-oriented queries across that for aggregation purposes. That it does very well. So it performs very well in that kind of use case. Now SQL Server can do that if you move your data into something like a SQL data warehouse and you do aggregation there and you're storing it there and you're doing your analytics there. But it requires another tool. Cosmos DB gives you the ability to do that in the cloud with a PaaS offering, something like that. So that's some for instances that you might want to think about. Cosmos DB also does document databases. So if you want to store things that are arbitrarily arbitrary documents, that would be one of use case that you might have that you wouldn't be able to. You can do that in a SQL server, but Cosmos DB gives the ability to query those documents. While that's a little bit harder to do inside of a SQL database, doesn't mean you can't do it in a SQL database. I did correct that. I can't see your code. Sorry about that. I moved it over there. Is in my airboard, could I model a multi-flight with an airport as a node? Yeah, you can do that. It does give you the ability to do that. Not in my demo, but with Cosmos DB and the Gremlin, you can write queries to find the shortest path between 2 points, for instance, and you could do that to model finding possible routes from one airport to another airport. Or if you had something like costs baked into those routes, for instance, you could find the lowest cost route. It might be more routes, but it might be the lowest cost route or something like that. So yes, with something Cosmos DB and the Graph API and Gremlin, you can do those kinds of queries. It does give you the ability to do that kinds of things. Is there a version of Cosmos DB available for running outside of Azure? The answer to that is yes. There is 2 available versions for running this outside of Cosmos. There's the emulator, which is usually for development purposes, and Microsoft is moving Cosmos DB into Azure Stack as well as putting it on Azure on the Azure Edge. I'm sorry, IoT Edge as well. So there's going to be a version of it for that as well. Those are, I don't know that those are in production yet, or GA yet, but those are coming. As of right now, the only way to run Cosmos DB is on Azure, and the emulator if you want to do dev work, so you don't incur costs. What would be a strategy to import a lot of data to Cosmos, say 100 gigabytes of data, using the table API quickly? Hey, that's a good question. I would use there's some migration utility. Azure has a utility for that. First, you would want to figure out how you want to partition that data first, so that you set your partition key up correctly, so that data import goes in well. And then once you have your data imports ready to go, you want to scale out your Azure Cosmos DB to where you have your partitioning set up as well as a lot of RUs available. Do your bulk load in and then scale it back down to what what you need for your production app. So that might be a strategy for importing literally hundreds of gigabytes into Azure or something along those lines. What about backups? The ability to do backups on Azure with Cosmos DB isn't baked into the platform. You can back your data up by doing by querying the data out of Cosmos DB through one of the APIs if you need to, but they also have baked in the data itself is written 3 times in any instance of Azure. So any byte that's written on Azure, regardless of what kind of storage it's written to, is written 3 times. And so as far as to my knowledge, there is never been any data loss on Azure as a fault of Microsoft. So you would have to keep your data backups available by writing the data elsewhere, and also doing you can do data read-only replicas to other data centers and things like that for failover and things like that for data redundancy and things like from a backup strategy as well. If I have a locally hosted Mongo database that I want to host on Azure Cosmos DB, are there limitations to the size of documents and the collection size? I don't, as far as to my knowledge, there's not any limitations on the size of the documents. The caveat for running Mongo on Cosmos DB though is that the document database will, I don't say penalize you, it will cost you more for larger documents because the way that it reads and writes documents, it doesn't do sub-document updates on it. So you would have to literally download and re-upload the data whenever you're doing that. So you might want to make sure that your documents are reasonably small so you don't incur a lot of RUs, especially for a lot of code, a lot of things related to that. Where can we download your code for your app source today? We'll be posting the code to with a link whenever we do publish this video. I can give you that code, or you just shoot me an email and I can zip it up and send it to you, and I'll be glad to send that out to you. It's not proprietary. It's I've used that demo many times. I did have to update it too, because if you've seen another demo with that using another API that was available for Microsoft, it didn't work when I went. So I did a really quick update before this demo. Wouldn't you think? Another question here. Let's see what I got here. Wouldn't you think that NoSQL database wouldn't you think of NoSQL just as adding records? Example, John Doe with a white car on Monday is a record, and John Doe with a black car on Tuesday, but not update the first record. No, I don't. I don't think you would never update records on a NoSQL database. There are use cases when you want to update records. It just the question is what are you trying to do with that? And the issue there is what's the use case. Now, if you just need a forward write, if you want to do a write only where it never changes type scheme with Cosmos, certainly you could do that. I don't. I mean, but there are certainly use cases where you have things on Cosmos DB that you do need to update, and it does provide you the ability to do that as well. So that's, I think, the last question. If there's no more questions out there, it's 3 o'clock, and that'll wrap up our webinar. Unless there's no more questions, it was a pleasure to give you a tour of Cosmos DB, and I hope to see you on future Wintellect webinars, and hope that everything, I'll be posting the code out there, and we'll be posting the video so you can review this in the future. Thanks for your time, and I hope that you have a great afternoon.